Hello, class. Here we go. 7.4. It's the last section we'll cover in chapter 7. It's another type of hypothesis test. It's for a proportion. So we're looking at the key word here is proportion, not a mean. So you're not going to see anything about standard deviations or means. You'll see a lot of P's, and we'll try to break down all of that. The good news is you're going to use the normal distribution. So that's the Z distribution. So you should have all Z scores for this one. So it'll be like 7.2 in that way. And then there's your steps. Similar to what we've been doing, new formula. In that formula, you've got P hat, P, and Q. I'll break those down within the example below, okay? But in step 4, notice you're just doing just like 5.1, right? Which is just like 7.2, so there'll be a lot of repetition here. And then these we've been doing all chapter. Okay, so let's get right into an example and see how it goes. So the first thing you're going to do is, like always, state your HO and HA. Okay, the claim is P less than 3.4, the proportion less than 0.34. And since that's less than, it's a left-tailed test. So all this stuff feels familiar. H sub 0, flip it around and reverse it. And why are we using P? Because that's the variable for population proportion. So anytime you see lowercase p, it's going to stand for population proportion. Okay? So we're making a claim about a population's proportion, like percentage, that kind of thing. Okay. Next step, there's this verification thing. I'm not really going to focus too much on that. Basically, you're just making sure that if you're asking a bunch of people their opinion, you need at least 5 on either side. Okay, so like in this example, it's kind of a general example, but you're asking 200 people and 65 respond with some answer, right? So that's enough. So that means 200 minus 65, 135, answered the other way. Both of those are larger than 5, so we're good. That's all you're worried about there. Okay, so let's get right to the meat of the problem and finding that z-score. And I'm going with that formula right there, right? And the first thing you see is a p hat. Okay, so make a note of this. P hat is the sample proportion, and you can think of that as a little formula, x divided by n. Okay, so in this problem, we have the x and the n. So it's basically you're finding the percentage of people that think one way or the other. So in this problem, my p hat, just write it up here. It's going to be 65 divided by 200. Okay. 0.325. All right. So that's what I'm going to put for p hat, 0.325 minus p. Anytime you see p, just look back at your hypotheses and use that number. So that's going to be the 0.34. Right? And then we've got this square root in the denominator. P again, 0.34. And then there's a Q. Now, if you remember back from our probability sections, Q, oops, not Q hat, just Q, is equal to 1 minus P. So in this case, that's going to be 1 minus 0.34, which is 0.66. Okay, that's what I'm putting here. So maybe let's do times 0.66, right? And then divide by n. N is 200. Typically, that's your sample size, how many people were surveyed. Okay, so that breaks down all of the variables in the formula and how to find them. Now I'm just going to do the calculation. When you do this calculation, you can put it all in your calculator at once. Maybe put parentheses around the top would be good to get the order of operations correct. Okay, so if you want to practice and see what you get, and I'll see what I get, and hopefully that'll match. So what I'm getting, and I'm rounding to 2 decimal places because it's a z-score, negative 0.45. Let's make that a better 5, a better 4, 5. 4, 5. There, that looks nice. Okay, so 4, 4, 7, 8, rounding to 4, 5. Okay, what's our next step? If I look at my steps, we just did step 3. We're on to step 4. We need to find that p-value, and that's the area under the standard normal curve. And you can use your table for that. Probably, if you just have your table handy, that's probably just the simplest way. It's a left-tailed test, so you just got to look up that value directly right in your table. So I'll look it up on mine here, and I can just share that with you real quick. I'm doing just to review that. We're going to the standard normal distribution, negative 0.4, and then over to 5. There it is. So 0.3264 is what I want. Okay. All right, so going back to the handout. P-value is 0.3264. Is that right? Okay. Next, what do we do? This all should be the same as what we've been doing with p-value methods. Compare to alpha. So obviously this p is larger than alpha, right? P larger than alpha. And when that happens, it's always fail to reject H sub 0. If P was smaller, you would reject H sub 0. So we have a fail to reject H sub 0. If I now try to make my final conclusion, the interpret decision, I have failed to reject H sub 0 linked with HA is the claim. So you can go back and look at your conclusion. It's back on page 2 of this handout. You can look it up and then you just write the sentence. This one there is insufficient evidence to support the claim. Sorry, I ran out of room. Okay. And there we go. That's how that one works. All right, let's try one more on this video, and then we'll stop there for now. But here we have a researcher center claims at less than 50%. There's your claim right there. So I can just start right in, HOHA, P less than. It's always good to convert those percentages to decimals. There's the claim. Percentage is less than 50%. All right. So H sub 0 greater than or equal to 50%. So it looks like we got another left-tailed test. Okay, let's get the z. So let's see, how about a p hat? That's the first thing. If I read this, in a random sample of 100 adults, 39% say they have access if they have access to the internet. So here, notice in this problem, you don't even have to calculate the p hat. It's already given as a percentage. That's the p hat, 0.39. It's the percentage based on the sample. Okay, so there's the difference on these problems. Sometimes you have to calculate it because you're given the number of adults out of a total sample. And you have to find the percent, or you may just be given the percent directly. Right? That's where that p hat comes from. Minus p, always use the value from the hypotheses, okay, over square root p again, and then there's that q is 1 minus p. If you want to write that over here somewhere, 1 minus p, 1 minus 0.5 is 0.5. So we got a 0.5 there as well. Divided by n. N is the sample size. There it is, 100. Okay, and we're off to calculating this guy. Parentheses around the top to remind myself. Do that first. Okay, I'm getting a negative 2.2 on that. Okay. Cool. That's step 3. Step 4, convert that into a p-value. Again, it's a less than left tail. It's the easiest one because you just go right to your table and look it up. So I won't bring it up. I'll just do it negative 2.20. Right, that helps, right, to look it up. Look at negative 2.20. And I'm seeing on that one a 0.0139. Okay, there's my p-value. 0.0139. A note of all these p's floating around. This is a this is a capital P. That's a p-value, probability of the sample occurring, opposed to this lowercase p, population proportion. Confusing, right? Because they're both p's. So just look for lowercase versus uppercase. Lowercase, population proportion. Uppercase, p-value. Sometimes instead of just writing p here, maybe just say p-value. And that might be a little bit more clear. Okay, and then what are we doing? We're comparing that to the level of significance. Ooh, it's close. That's 1%. This one's slightly larger than 1%. P is larger than alpha. Fail to reject H sub 0. And we got the same conclusion as the first one, right? Because HA was the claim. Fail to reject H sub 0. Maybe I should get some more variety in these conclusions, huh? We keep getting this. There is insufficient evidence to support. The claim. We can't support the claim that less than 50% of the US adults have access to the internet, right? Because we see the sample only 39% have, basically. Okay. Yeah. You know, that's the weird thing is on this one, it feels like you should support that, right? Because 39% is less than 50. And if you had a different level of significance, you would, right? Like, you know, another typical level of significance is 5%. That's usually the one that's done a lot in research. This is p-value is definitely less than 5%. If that were the case, you'd reject H sub 0 and support H sub A. All right, so there's that. Okay, anyway, gotta stop there. See you next time. Bye.